Good morning, everyone. We are Edmund, Agnes, and Andrew. Welcome to our final Bucky Lab presentation. So, let's start with the problem. Current standard work facilities do not meet the needs of modern work practices. Today's working methods demand spaces that offer flexible facilities to support multiple functions simultaneously, whilst meeting sustainable targets for a circular economy. We have solved this demand through the design of our smart, adaptable, bio-based furniture solution. Introducing Flip It. Now one space can function as many. Flip It is a mobile work surface that can be easily and safely transformed into a room divider. Adjustable heights enable the surface to be tailored to your ergonomic needs, be it sitting, standing, or somewhere in between. Made from a mix of E-core panels, timber, and recycled plastic, Flip It is durable, circular, and innovative. Modular applications, replaceable work surfaces, and passive acoustic functions make Flip It the optimum tool for flexibility in the CEMIC makerspace. So, how does it work? The product is comprised of three key components. Number one, the cabinets. These ground the unit and facilitate the lifting and flipping functions. Number two, the table supports. These connect the cabinets via the axle to the table surface and are used to flip it into a room divider. And finally, the table surface itself. Let's start with the flipping and lifting functions, which are housed in the cabinets. Gears made from 6-ply flat core are used to drive the lifting and flipping mechanisms via rack and pinions. Both systems use parallel axis self-locking gears and have the same ratios. The ratios increase the torque used to drive the lifting and flipping mechanisms relative to the input force, making the mechanisms easy to operate. Here we can see the gears on one side are used to lift the table. And the other side to flip the table. We built this model at 1:2 to demonstrate that one cabinet could drive the other via an axle and prove that the self-locking gears could function. As you can see, the flipping mechanism and the self-locking gears work very well. However, the lifting mechanism requires more fine-tuning. Now let's look at the locking pin. This feature was added as a fail-safe in case the self-locking gears slip. A spring-loaded pin is mounted within a stationary part of the cabinet. When released, the spring pushes the pin through a hole in the moving part of the cabinet. Twisting the green handle by 90 degrees prevents the spring from engaging whilst Flip It is transforming. Here we can see a 1:2 prototype demonstrating how the 90-degree turn locks the spring. Now let's move on to the table surface. The surface is a composite panel designed to be self-supporting. This aids a 400mm cantilever from the cabinets in each direction. The surface is comprised of 4 parts as seen here from left to right. 1. A replaceable sheet of single-ply flat core. Mounted on number 2, a layer of 20mm light core. On top of number 3, a sheet of wave core, and all housed within a frame of light core finished with HPL. This is the table surface fastener. The dowel part is mounted within the light core layer of the table. This video demonstrates how the replaceable flat core slips over the dowel, as you can see here. Then, by pushing the plug into the dowel and rotating by 90 degrees, your new top layer will be secure. We were able to test this concept at a 1:1 scale using E-core panels. We're pleased to say it works very well. Moving on to our passive acoustic approach. An obvious secondary function of a room divider is to reduce noise pollution from one workspace to the next. We achieved this through use of the wave core, which has a profile suitable to deflecting sound. In addition, we have specified that 10mm holes are drilled down the length of the ridges to improve the sound absorption factor. So, let's put our product back together again and see it in its 4 modes. Low table, low room divider, high table, and high room divider. Through an iterative process of modeling, we determined that the optimum dimensions for our table surface is 1.4 meters squared. Let's have a look at how this impacts the CEMIC makerspace. We have been lucky enough to collaborate together in the same space for the past few weeks and have produced these models to test our ideas. Now we have reached the end of our design process, we are reflecting on these ideas. Although we love our oversized E-core gears, they would certainly be more effective if they were made from a traditional gear material, like steel. We have pushed E-core to its limits and therefore believe that Flip-It would make an excellent installation for the CEMIC makerspace. However, for the same reasons, Flip-It would not be suitable for mass production. One exception to this is the table surface. Given E-core's semi-durable properties and our successful prototypes, we feel that this component of the design would be well suited to the E-core mass market. So that's everything from us, guys. Thank you very much for paying attention. Here we are sat behind our finished product at the table.
We've had a great time these last couple of weeks. It was great getting to know all of you, even though it wasn't the normal way, but we hope to see you next year.
And as always, you can catch all of our stuff on the usual social channels. Flipit.online, flip_it.Bucky Lab on Instagram. So yeah, thanks. And
have a great summer, everyone.
Yeah, cheers.
Cheers.